In this video, we're going to check out where these Pythagorean identities exactly come from. I think this first formula, it doesn't matter the variable x or theta, right? We're in trig, so I'll do theta. Um, I think this one comes up often enough and is easy enough. Like, you might as well just have it memorized, but where exactly does this come from? Well, it's kind of in the title, Pythag. Pythagorean identities. Well, what is the Pythag? Well, uh, the sum of the squares of the legs, right? A squared plus B squared equals C squared. Old stuff, we all know that, but how is that sine squared plus cosine squared equals 1 exactly? Um, so let's change this. We have a theta, right? So it doesn't really matter, but we'll just call this theta. And therefore, if we're thinking in terms of trig, right, B is the opposite side, A is the adjacent side, and C is the hypotenuse. So therefore, I can rethink of A squared plus B squared equals C squared in terms of the theta and where these sides are located, right? Like A is now the adjacent side, whatever that is, squared. B is the opposite side squared, and C is the hypotenuse squared. We're almost there. Here's the trick to this Pythagorean identity and where it comes from. Notice the right-hand side equals 1, right? We want 1. All right, well, how do I get the right-hand side over here to be 1? Is divide this, right? Divide the hypotenuse squared. Divide everything, like I can't just divide one side. So therefore I divide everything by hypotenuse squared. And now it's easy to see the right-hand side, that's 1. So now if I claim that I have sine squared and cosine squared, I'm good to go. Well, it takes a little work. For instance, I see sine squared is first, and that's over h, right? Sine theta is opposite over hypotenuse, and cosine theta is adjacent over hypotenuse. So I can rewrite this as opposite over hypotenuse squared, right, plus adjacent over hypotenuse squared, because any square, right, like x over y squared is equivalent to x squared over y squared. So I'm using this form, opposite over hypotenuse squared, adjacent over hypotenuse squared, and that's it, because opposite over hypotenuse is sine theta, and adjacent over hypotenuse is cosine theta. And just by the style of writing trig, sine squared is written as sine squared, like that, sine theta squared, but they mean the same thing. So last note, like, why do they do that? Because if I wrote sine theta squared without parentheses, am I meaning like what I had above, sine theta, and then square it? Or do I literally mean take the sine theta, so I'll say or, the sine of some angle squared, right? It's not clear. It's doubtful, I'll just say this now, it's doubtful you mean this bottom way. Okay, we usually don't really have much use for squaring an angle and then applying a trig function, but you never know. Okay, so it was a little bit of manipulation. I think I probably even overkilled it. I think some of this could have been omitted, but you can see we started with Pythagorean theorem, And through some steps, we ended with the Pythagorean identity, sine squared plus cosine squared equals 1. Well, there are actually 3 of these. This is only one of them. But that is the blunt of the work. Okay, showing where that came from is really the blunt of all of the work, because the other two, they're as easy as divide everything, because I don't have the other two memorized, right? I could easily get them. But to get one of them, you divide everything by sine squared theta. And to get the other, we'll just use a new color here. Doesn't matter, we'll do green, why not? To get the other one, you're going to take everything, I'll go like this, and you're going to divide by cosine squared theta. So why would you do that? Because if you look at the forms, you'll see one of them has a 1, or they both have a 1 on the left-hand side. In order to get 1, divide by whatever you need to do, okay? Let me erase that green because it actually was going purple. So let's rewrite this and show the work. So to get the second, we're going to do sine squared plus cosine squared theta equals 1, but we're dividing everything by that sine squared. All right, now I explained how a squared over squared, we could think of it as one term to the right, so I'm not even going to write all that. To finish this up, sine squared divided by sine squared, this will yield our second formula, is 1. Cosine over sine, right, is cotangent. So cosine squared over sine squared is cotangent squared. 1 over sine is cosecant. So 1 over sine squared is cosecant squared. Bam, done. There's number 2. All right, for the third one, again, I'm going to rewrite it just so that we have the formula. But I'm claiming let's divide everything by cosine squared. Well, once we simplify and change, we have our third equation. Sine over cosine is tangent. So therefore, sine squared over cosine squared, tangent squared. Okay, then we have 1. Anything divided by itself. 1 over cosine is secant. So 1 over cosine squared is secant squared. All right, and that is it. Let me just highlight these all. Yeah, blue is fine. Okay, there's equation 3, equation 2, and equation 1. I highly recommend memorizing equation 1, because then you can manipulate it to get the other 2, and it's easy enough. But if you ever forget them, the work to the right shows where they come from.